Thank you to all. I am Dr. Gauss'S, Associate Professor in EC Department. So today I have discussed some topics which is related to the antenna and wave propagation, Unit 1. The gradient of a scalar field. What is the meaning of gradient of a scalar field? What is the significance of gradient of a scalar field? How we find the gradient of scalar field in different coordinate system, and how we find the divergence of different coordinate system, and how we calculate the curl in different coordinate system, and what is the physical significance behind that. So we discuss here. And according to the gradient divergence curl, so I also discussed the Gauss divergence theorem and Stoke's theorem. So first I talk to you, so what is the meaning of a gradient? So gradient of a scalar field, so we know that how we find the gradient. So gradient always to be taken by the scalar field, and the output is vector field. So gradient of a scalar field V, suppose V is there any scalar field. So in terms of the electromagnetics, so we suppose if V is a voltage. So if we find the electric field, so we know that what is the relation between the electric field and the voltage, which one is minus the gradient of V. So if we find the scalar field, so if I having a scalar field in the scalar form is V, and we find the gradient, so gradient which represent a vector field having a magnitude and direction of the maximum space rate of increasing of V. So we see that if the voltage V1 is here and the V2, if this is increased having a voltage of delta V, so how much rate is to be changed? So we calculate by the gradient. So gradient, what is the physical significance of gradient? So if any scalar field, if we taking a gradient, so that means the having a magnitude and direction. So in what space and what is the maximum speed rate change increase of V, so we calculated by the gradient. And how we calculate the gradient? So we calculate the gradient in different coordinate system. First one is Cartesian coordinate system, second one is cylindrical coordinate system, and third one is spherical coordinate system. So this is very important question which has to be asked in Unit 1 in UT examination as well as the PUT examination and the other examination. Ki what is the formula for gradient of V if any scalar field V, and you find how you find the gradient of that particular scalar field in different coordinate system. So in Cartesian coordinate system, we easily calculate by if the V is the scalar field, so we calculate by gradient of V by using the formula del V over del X AX. So AX is the direction of in that particular unit vector in the direction of X, and AY is the unit vector in the direction of Y, and AZ is a unit vector in the direction of AZ. So we easily calculate the gradient of any scalar field by using the formula del V over del X AX plus del V over del Y AY and del V over del Z AZ. But in the cylindrical coordinate system, how we calculate it? In the cylindrical coordinate system, we know that the differential length in cylindrical coordinate system, so the which one is d rho a rho plus rho d phi a phi plus dz az. So in the cylindrical coordinate system, the differential length is d rho a rho d phi a phi plus dz az. So the multiplying factor which have to be here, which one is h1. So the multiplying factor is 1. But in this case, the multiplying factor according to the a phi direction, which one is rho, and in the direction of az direction, what is the multiplying factor, which one is 1. So we easily calculate the gradient of any scalar field if the scalar field is given in the cylindrical coordinate system by using a formula del V over del rho, and what is the multiplying factor of h1. So h1 is in this case is 1. So gradient of V, which one is del V over del rho a rho into 1 upon h1. h1 is 1, so that means the value of this is del V over del rho a rho. But in the case of this, if we taking what is the 1 by h2 factor? 1 by h2 factor is 1 by rho. So we put this vector is 1 by rho, and if we partially differentiate with respect to the phi, del v over del phi in the direction of a phi. In other cases, in S3 case, 1 upon S3 is the 1 by 1 and del v over del z az. So by using these factor, so we easily calculate what is the gradient of any scalar field in cylindrical coordinate system, which one is del v over del rho a rho 1 plus 1 by rho del v over del phi a phi plus del v over del z az. So in a similar fashion, we also calculate the gradient of v in spherical coordinate system, where h1, the multiplying factor or differential length, in this case, which one is a dr ar plus r d theta a theta plus r sin theta a phi d phi. So in this case, the multiplying factor is 1 r sin theta. So the multiplying factor here is 1 r, here the multiplying factor is r, and here the multiplying factor is r sin theta. So we easily calculate the gradient of v in the spherical coordinate system, which one is equal to the del v over del r ar 1 by r del v over del theta a theta plus 1 by r sin theta del v over del phi a phi. So we just solve the example. Okay, if the gradient of this scalar field, you have to find it by using the previous formula, which has to be I discuss here. So this one is, first one is the case of Cartesian coordinate system, second one in the case of cylindrical coordinate system, and third one in the case of spherical coordinate system. So in both the cases, how we find the gradient of a scalar field v? So just we can say, for first case, v is equal to e raised to power minus z sine 2x cos hyperbolic y. So the question is asked to you, in 2 marks question, we have to be asked to you ki if the scalar field v is defined by e raised to power minus z sine 2x cos hyperbolic y, and you calculate what is the gradient of that particular scalar field. So you easily calculate, we know that the gradient of v in case of the Cartesian coordinate system, which has to be defined by del v over del x ax plus del v over del y ay plus del v over del z. This is the formula we have to be already calculated. So what is the gradient of v in Cartesian coordinate system, which one is del v over del x ax plus del v over del y ay plus del v over del z az. So in this case, the v is defined here. So this is the scalar field v. If we differentiate this, so the value of this is 2 e raised power minus z cos 2x cos hyperbole y in the direction of ax, because in the del v over del x case, you have to be just constant as a y and z as a constant, and you have to be just differentiate this vector field v with comparison to the x. But in the case, if we and the next term is, if we calculate the del v over del y, in this case x and y which are constant. So if x and y are constant, so we calculate what is the differentiation of that particular vector, that scalar field, e raised to power minus z sine 2x cos hyperbolic, the differentiation is sine hyperbolic y. So we easily calculate e raised to power minus z sine 2x sine hyperbolic y in the direction of ay. Plus, in this case, and the third vector is del v over del z az. In this case, x comma y as a constant, and we partially differentiate the scalar field v with respect to the z. So we know that what is the e raised to power minus z? E raised to power minus z is equal to minus e raised to power minus z. The differentiation of e raised to power minus z is minus e raised to power minus z. So we minus e raised to power minus z, and these x and y are constant. So we put is sine 2x as it is sine 2x, and cos hyperbolic y as it is cos hyperbolic y in the direction of az. So we easily calculate what is the gradient of any scalar field in the Cartesian coordinate system. So first question we have to be solved. And second question which we ask in cylindrical coordinate system, this is different to the previous one. So we know that the cylindrical coordinate system points are rho, phi and z, and we know that this is rho, this is phi, this is z. So we identify this system is a cylindrical coordinate system, and we find the gradient of in that particular cylindrical coordinate system. So what is the formula behind that? So we easily calculate del of u is del u over del rho a rho 1 by plus 1 by rho del u over del phi a phi plus del u over del z a z. So we easily calculate is 2 rho z. In this case, rho is the variable and z and phi is the constants. So rho square, what is the differentiation of rho square? Which one is 2 rho? So 2 rho is the differentiation of that, and we and second terms is z and phi are constants. So 2 rho z cos 2 phi a rho. So we easily calculate by using these identity del u, which one is del u over del rho a rho plus 1 by rho del u over del phi a phi plus del u over del z a z. So by using these identity, we easily calculate what is the gradient of that scalar field u in terms of cylindrical coordinate system. So this is the answer. So we easily calculate. And third one is the scalar field w, which is defined tan r sine square theta cos phi. So we know that the component, the direction of unit vector in spherical coordinate system are r, theta and phi. So if we correlate this, so we identify this is a spherical coordinate system. So if by using the how we find the gradient of that particular scalar field, if I give this vector field is given in the spherical coordinate system, so easily we have to be calculated del v is the gradient of w, which is defined by del w over del r ar plus 1 by r del w over del a theta plus 1 by r sin theta del v over del phi a phi. So we easily calculate w with respect to the r, and where theta and phi as a constant variable and r is the variable, and in this case the theta is variable and r and phi are constant. In this case r and theta are constant and the variable are phi is variable. So with respect to the phi, we have to be differentiate here. With respect to the theta, we have to be differentiate here and multiplying 1 by r in the direction of a theta. In this case, only r is the variable and theta and phi are constant. If we differentiate w scalar field with respect to the r, so we easily calculate what is the gradient of different gradient of w in spherical coordinate system. So next topic is divergence of a vector. So this is quite different between the difference between the gradient and divergence. So divergence always is to be taken by any vector field. Always we have to be sincere about that. Ki divergence is to be calculated by any vector field, and the output also a scalar field. So if we taking a divergence of a vector field which gives a scalar field, but in the case of gradient, we have to be we find the gradient in a scalar field, any scalar field which gives the output in vector form. But in the case of divergence always is to be taken of a vector field and they give the output in the scalar field. So divergence of a vector is given point P. So this is a point P. This is the outward flux per unit volume where the volume shrinks about P. So that means what is the meaning of this? So divergence always to be taken how much flux is to be evaluated that particular point, that is called the divergence of that particular vector. If I can say divergence are 3 types. So that means the positive divergence, negative divergence and zero divergence. So in this case we see that this is a point P. This is a very small point P, if your electric flux is to be illuminated from here, that means if the point P just like a source, so we can say the divergence about the P is positive divergence. If this point P as a sink, so that means all the electric flux or electric field line and magnetic field line is to be converged here. So we can say this is the negative divergence. If the point about the point P, the electric flux or magnetic flux is constant, so we can say this is the zero divergence. So because not to be converged, not to be diverged, so we can say this is a zero divergence, or we can say solenoid. So this is the show of positive divergence, negative divergence, and zero divergence. So what is the how we calculate the divergence of any vector field in different coordinate systems? So first one is the Cartesian coordinate system. Second one is cylindrical coordinate system. Third one is spherical coordinate system. So in this case, if vector A is defined, then how we calculate that this is del operator. So del dot A is equal to del AX upon del X plus del AY upon del Y plus del AZ upon del Z. So easily we have to be calculate the divergence of any vector in Cartesian coordinate system, but in the case of cylindrical coordinate system, we have to be calculated by del dot A, which is equal to 1 by rho del over del rho rho A rho plus 1 by rho del A phi upon del phi plus del AZ upon del Z. So we easily calculate what is the divergence in the case of cylindrical coordinate system, but in the spherical coordinate system. But in the spherical coordinate system, we have to be calculated by 1 by r square del over del r square AR plus 1 by r sin theta del over del theta, A theta sin theta plus 1 by r sin theta del A phi upon del phi. So we easily calculated what is the divergence of any vector field, so which give a scalar field. By using this formula, we easily calculate it. So the property of the divergence, it produces a scalar field. So that means that if I diverge of any vector, so that means they produces a scalar field. The divergence of a scalar V, divergence make no sense. That means that if I can say the scalar field, if we find a divergence of a scalar field V, so this is the no sense. So because always we have to be mind that always divergence to be evaluated by the any vector field, not a scalar field. So if I can say the divergence of A plus B, which is equal to the del dot A plus del dot B. If I can say two vectors are sum here, that means A is the any vector plus B is the any vector. If we find the divergence of that particular vector, so we easily calculated by del dot A plus del dot B. So this identity is to be involved in the divergence vector. And this also, if we multiply any scalar field to any vector field, so the identity is V into del dot A, which is equal to the A of dot del V. So this is the gradient, this is the divergence, this is the gradient. So this is the identity to find the what is the divergence of a vector field. So what is the divergence theorem? So this is very important. The Gauss divergence theorem, or we can say divergence theorem, states that the total outward flux of a vector field A at the closed surface S is the same the volume integral of the divergence of that particular vector. So how we calculate the total outward flux? So if I can say vector A is defined here, so the total outward flux, that means the total outward flux is to be defined by the A dot ds. So that means the divergence of, if we diverge that particular surface area, so they produce a total outward flux. So that means it states that, what is the states that the total outward flux of a vector field A. So what is the significance of a total outward flux? We have to be calculated by the surface integral of the A dot ds. So the total outward flux of A, which is the equal to the same volume integral of divergence of A. So what is the significance of this? Same as the volume integral. So this is the volume integral. This is the volume integral. This is the volume integral. This is the volume integral of divergence. So divergence, how we calculate it? Del dot A. So this is the method. Gauss divergence theorem is the method to convert the surface integral to the volume integral. So that means if I can say the total outward flux, which is equal to the volume integral and the divergence of that particular vector, that is called the divergence theorem. So how we calculate the total outward flux? Total outward flux we have to be calculated by the A dot ds. So this is the A vector, and this is the A dot ds is the total outward flux in that particular surface, which is equal to the volume integral of that divergence of that particular vector, that is called the divergence theorem. So this is the derivation of Gauss divergence theorem. This is very important of unit 1. You have to just state the Gauss divergence theorem and the proof of the Gauss divergence theorem. So this is the any closed surface we have to be divided here, and the volume is V. So what is the meaning of, if I can take this LHS A dot ds? So A dot ds is the LHS side. So if the summation of that particular vector is S, so if we divided and multiply the here volume, so that means this is limit S tending to K, A dot ds divided by delta Vk and into delta Vk, where delta Vk limit, if delta Vk tending to 0, so this vector is going to convert into that particular del dot A. This is the divergence of that particular vector. This shows what is the divergence of that particular A. This is the definition of divergence. Key. That means that if your what is the total outward flux per unit volume, where volume shrink about the P of volume tending to the 0. So that means this is the divergence. This is the divergence of that particular vector, and this is delta Vk. So we easily calculate what is the volume integral, and if we denoted by here, so what is the dV? So we easily calculate what is the LHS. LHS we have to be taken here, A dot ds, and which produces del dot A dV. So we easily prove that the Gauss divergence theorem according to the what is the divergence of that particular vector. This is the example for finding the divergence in different coordinate systems. This is the exercise you have to be taken. What is the P? If P is defined here, we know that always divergence to be calculated by any vector field, and the output is the scalar field. So P is defined x square y z in the direction of ax, xz in the direction of az. So we easily calculate y with the formula del over del x plus del p over del y equal del p over del z. So we easily calculate this is the vector field. So always divergence always give it the scalar field. So by using a formula, we also calculate the divergence of that particular vector in a cylindrical coordinate system. But you remind that what is the formula to calculate the divergence in cylindrical coordinate system. So which one is 1 by rho del over del rho d rho plus 1 by rho del q phi upon del phi plus del qz upon del z, where q is the vector field. So we easily calculate, and you have to just solve this question. This is very important question to find what is the divergence of any vector. So but in the case of the spherical coordinate system, we have to be easily calculated. This is the formula, how we calculate it, and you put the value of this del over del r. So we easily calculate what is the divergence of that particular vector w, which is defined by the 2 cos theta cos phi. So Gauss divergence, I already we have to be calculated here. So this is the problem which has to be asked in university exam. Very important question. This question is to be referenced by Matthew and Sadiku. I have to be taking this example, and this example also asked in 2023, 22, 2019. Same question we have to be asked here. And what is the problem is here? If GR is the vector field which has to be here 10 e to the power minus 2z rho arrow plus az. So we can say this vector field is defined in the cylindrical coordinate system, and you determine the flux of G out the entire surface of the cylinder, where rho is equal to 1 and z is lies from 0 to 1, and confirm the result using the divergence theorem. So how we calculate it? So first we write what is the Gauss divergence theorem in terms of the vector field G. So we know that the surface area in a closed surface, which one is equal to the G dot ds, the total outward flux, which is equal to the, what is the meaning of this? The volume integral. So what is volume integral? Volume integral, triple integral. Which one is the divergence of that particular vector? So we easily calculate the LHS side and RHS side, and we find that the total outward flux by using the calculator G dot ds, and if we find the divergence by using the del dot G, and we integrate it according to that particular volume, so the answer is same, and we can say the divergence theorem is to be verified. So suppose this is a cylinder, this is the outward flux from these sides, so we can say this is side flux, this is top flux, this is bottom flux. So the total outward flux is to the algebraic sum of side flux, side plus top plus bottom. So if we calculate the total outward flux in terms of side, top, and bottom, if we integrate it, this is equal to the G dot ds. So this is equal, and how we calculate this? So you know that this is the z axis, and this is the z is equal to 0, and this is the z is equal to 1, because this is the z is equal to 1 plane, and this is the z is equal to 0 plane, and rho, the radius lies from 0 to 1, so this distance should be 1. So that means which is given in that particular question, rho is equal to 1, that means the rho is equal to 0 to 1 and z is from 0 to 1. So we easily calculate the top flux. So what is the top flux? So this is how much top flux is to be calculated. So side top we have to be calculated by G dot ds. So in this direction we know that what is the surface area we have to be here. So this surface area is to be here. So we know that the differential surface area in the direction of AZ, because this is the AZ direction. So in the direction of AZ, what is the surface area? Rho d phi. So this is the surface area in the direction of AZ. So we put it rho d phi. So rho d phi, this is the surface area in the direction of arrow, or we can say in the direction of arrow, and arrow. So what is the magnitude of G in the direction of arrow? Which one is 10 e to the power minus 2z into rho. So we put it 10 e to the power minus 2z into rho, and z is at top, z is equal to 1. So we put is z is equal to 1. So 10 e to the power minus 2. So 10 e to the power minus 2 here, and we and rho is also here. So rho is also here. So that means we have to be put it and give the results, which one is 10 pi e to the power minus 2, and we put the limit. So here are the two variable, rho and phi. So we know that rho is lies from 0 to 1. So this is the rho is equal to 0 and rho is equal to 1. So we put the limit of rho is equal 0 to 1, and phi is, this is the angle phi, and phi lies from 0 to 2 pi. So they produces a cylinder. So we put the phi is equal to 0 to 2 pi and we integrate it. So we give a answer 10 pi e raised to power minus 2. So easily we have to calculate the top outward flux, then we calculate the bottom outward flux. So at that case bottom outward flux z is equal to 0. So we put the z is equal to 0 here. E raised to power 0 is equal to 1, 10. So this is 10 e raised to power 0. And the ds in the direction of az, which one is rho d rho d phi. So we easily calculated what is the bottom flux. Bottom flux is minus 10 pi. So but in the case of side flux, so side flux is here in the direction of arrow. So in the direction of arrow, the ds is defined here. In the direction of arrow, the ds defined is rho dz d phi. So we rho dz d phi is here, and at rho is equal to 1, because in the at that surface rho is equal to 1. So we put it rho is equal to 1 here, and we also calculate the what is the side flux. So side flux we have to calculate the g dot ds. So g we have to be put here and ds is put here, and we apply a limit phi is equal to 0 to 2 pi and z lies from 0 to 1. So we easily calculate that the side flux is here. So if we added side flux, bottom flux and top flux, so the total outward flux we have to be calculated, which one is the total outward flux is top, bottom plus surface. Top we have to be calculated, bottom we have to be calculated, and side we have to be calculated. So we can say if we add it, so the total outward flux is 0 by using a volume integral. So we calculate is del dot g here, and we put the what is the divergence of in cylindrical coordinate system we have to be calculated by this, and we put it. So we can see that this is also a 0, and by using the Gauss divergence theorem we have to see that this is also a 0, or we can say g dot ds we also calculate the what is the total outward flux, which is equal to 0. So this is verified in both the cases if we calculate the total outward flux of g dot ds, or by using the volume integral del dot g dv, we see that the total outward flux is 0. So we can say the Gauss divergence theorem is verified by this question. Thank you.